Hello viewers, this is part 3 of answering your questions from AskPhysics. So SaintSoldier, this is question list from SaintSoldier, and this is the first of probably 3 parts of some of the questions that was asked. The first question that he submitted: what is the force F the man needs to apply to the crowbar to move the rock? What will the force on the fulcrum be? So here, this is just a lever, and we are making some assumptions here. We know that from here to here is 2 meters, so we know here this length is simply 1.4 meters. We're going to assume a rock is a small point at exactly this position, and the man pushes down exactly here. So in this scenario, the fulcrum is exerting a normal force upwards, while both the man and the rock exert downwards forces, and we know that they must balance. So we need the balancing of torques. Let's first take a look at the torque on the left side. We know the force is what we need to find, and it's at 1.4 meters, because torque is simply equal to force times the distance from the pivot point. We're looking at torque on the right side. We have 0.6 meters times the 200 kilograms, and we know we're looking at the acceleration of gravity, which is 9.81. We could say negative 9.81, but for the purposes of this question, that does not really matter. So 0.6 times 200 times 9.81, we get 77.2 Newton meters of torque. And we know that the torque on the left side must balance the torque on the right side for the man to be able to move the rock at all. So F times 1.4 is equal to 1177.2. And sorry, this is from another question. I'm just going to erase that, it's irrelevant. Force is thus equal to 840.86. We can just take 3 significant digits, so 841 newtons. Now, how reasonable is this? Well, if we take 841 and we divide it by 9.81, we get how many kilograms of force at gravity that will be exerted, and this is about 85.7 kilograms. So the man will still have to be putting nearly his entire body weight onto this lever to be able to move the rock. What force will the force on the fulcrum be? Well, the fulcrum only has the force from the rock, and the force from the man. The force from the rock is 200 kilograms times 9.81, and the force from the man we already worked out to be 841. So here we just plug this in to the calculator, 200 times 9.81 plus 841, and we get 2803 newtons. And this is the force on the fulcrum.